We're going to look at solving inequalities, but we're going to use something called, or a method that's a little different than what's commonly taught. We'll call it using number lines. Okay. So the very first thing is they've given us a function, and they want to know when the function is less than and equal to 0. So in other words, when the function is negative is what they're looking for. Now, in order to do this, we have some cubic function here, right? There's a little graph. It's a negative cubic function, so it probably does something like this. Okay. Now, here's the problem. They want to know when it's negative. In other words, when we're below the x-axis. So they're looking for, assuming this is drawn correctly, we'll highlight it here. They're looking for all of this and all of this. But the easiest way to really figure this stuff out is to put our stuff in factored form so that we kind of have a much better idea of what our actual x-intercepts are. And unfortunately, we're not in factored form. So I'm going to quickly go over factor theorem to put this in factored form, and then we'll focus on the actual number lines and the inequalities. First thing I'm going to do is I'm just going to quickly common factor out negative 2. So we're left with x cubed plus 3x squared minus 6x minus 8. Is that right? Yeah. Okay. It's still going to be less than or equal to 0. So I need to factor this cubic function. So normally I would test a couple methods. I'm going to tell you that one of the factors is, oh, I had it here a second ago, negative 1. Okay. So one of them is negative 1. So if we're going to use our synthetic division, let's say we use our negative 1, and we're going to add. Okay, so we'll build our little synthetic division here to quickly go through this. We're going to pull all our coefficients out. So the first coefficient is 1, then a 3, then a negative 6, then a negative 8. Okay, so we bring down the 1. 1 times negative 1 becomes negative 1. We add, this would become 2. 2 times negative 1 is negative 2. And we add those two, we get negative 8. Sorry.
No, the positive 8.
Oh, yes, that's it. Sorry, I was looking at it, I didn't think it was right. Yeah, we multiply the 2, we get positive 8. Good. And we get a remainder of 0. That's what we're looking for. Okay, good. So when we go to put this in factored form, I have my negative 2. One of my factors, since that's one of the x-intercepts, is x is equal to negative 1. Think of it like you're bringing the negative 1 back over, so we do x plus 1 in a set of brackets. Okay, so we have x plus 1, and then the other set of brackets, we have x squared with a coefficient of 1 plus 2x minus 8. This can be factored very quickly using product sum, if you like. Two numbers that multiply negative 8 and add to 2, 4 and 2, and we need it to be positive 4. So x plus 4, x minus 2. Yay! Okay, so we've gone through all that factoring. We haven't even got to what we really need to do here. Looking for when this function is negative. Okay, so when is this thing going to be negative? What we want to do is we want to look at this like values being multiplied together. So let's think of it, and actually what I'm going to do is, I usually call this the A value. Because this is kind of outside of our brackets, there's a rule of multiplication that you can multiply in any order. I'm going to put it into one of the brackets. So I'm going to distribute it into one of them. Not all of them. If we do all of them, we're definitely wrong. But I'm going to put it into one of them just so the next part's a little theoretically easier for you to see. Okay? So I'm going to take this negative 2 and I'm just going to apply it to the first one here. Okay? So we now have negative 2x minus 2, x plus 4, and x minus 2. Okay. So we're looking for when less than 0, in other words, when it's negative. So think of this kind of like I have in maybe the first term, so A term, B term, and a C term. Okay? So let's kind of write it like this. So B or C, I should have used red, but I'll call it A. Okay. So in order for A times B times C to be negative, there's many different options. We either get all three being negative, so a negative times a negative times a negative. That'll give us a negative value. Okay, so put these brackets around because that'll help us visualize this. We need it to be negative. That's one version. Another version is if two of them are positive and one of them are negative, that gives us a negative. So we have to kind of set up all of our scenarios in this version. Okay. So in that case, there's a couple other. We do plus when this one's negative and this one's plus, or when this one's negative and both of these are plus. We're looking at all negative values, so these are all possibilities. So in other words, there are 1, 2, 4 scenarios to go through here. Okay. So how do I build these scenarios? Well, think of it like each of these, I'm going to set each of these brackets, just like in our scenarios, I'm going to make this bracket an inequality that's negative. So in order to do that, this will be our case 1, we'll call it. So case number 1, think of it like this. Negative 2x minus 2 is less than or equal to 0. That makes it negative. Okay. Our next version, do it in green here, x plus 4 is less than or equal to 0. Actually, I can't say equal to because we said we need it to be negative, right? So we're just going to say less than 0. And the third version is x, we'll do that in blue, x minus 2 is less than 0. Okay, so in these cases now we solve for x. Okay, so the case over here we get negative 2x is less than positive 2. Now I'm about to divide by a negative value, so that's going to flip this inequality. It's now going to face the other way. We're going to have x is greater than negative 1. So that's one key thing to keep in mind when doing inequalities. In this one here, we're just going to get x is less than negative 4. And in this one here, we're going to get x is less than positive 2. Whoops, that should be blue. X is less than positive 2. Okay, seems like a lot. This is where the number lines come in. I'm going to draw all 3 of these number lines. So for case 1. So number line 1, 2, and 3. Okay. And what we're going to show, I'll call this 0. Okay, so this will be our 0 on all the number lines. When x is greater than negative 1, apparently it's negative. So if this is negative 1, we're talking about all of this area because x is greater than negative 1 in that example. In this one here, it says when x is less than negative 4, so negative 4 to be 2, 3, 4. Here's our negative 4. So they said when x is less than negative 4. And then the other one is when x is less than the value of 2. 2 would be 1, 2. We could say that's 2. When x is less than 2. Well, I've run into a problem here in case 1. In order for this stuff to work, I need all 3 of them to be in the same area. So for instance, if this was highlighted over here, then I could say this is true because all 3 inequalities are passing that part. Because I don't have all 3 passing, my case 1 did not help. It wasn't helpful. So when we go back up here, case 1 served no purpose. It didn't give us an answer. So now we try case 2 out. So we try case 2 out. We make it positive, positive, negative. And we repeat this process many times, okay? So our value is 2x minus 2. We'll call this case 2. Number 2. So we have 2x minus 2 is, I'm going to do a lot of zooming up and down. Negative 2x minus 2 is, we're saying the first 2 are positive. So we're going to say greater than 0. X plus 4 is greater than 0. And then this is the one we want to be negative. I think it was x minus 2. I'm going to check it out. Yeah. X minus 2, x plus 4. Good. Okay, same scenario, solve for x. So in this one, we bring it over. We get negative x greater than 2. Divide by a negative, so it flips sides. Negative 1. Here we get x is greater than negative 4. And here we get x is less than 2. So we set these up again on the number line and see if they're all going to overlap. So we keep doing this till we get values that overlap. And we might get more than one answer. Like different cases might give us different answers. So we'll start this at our 0 again, we'll say. So when x is less than negative 1, if this is negative 1, we're talking less than negative 1. When x is greater than negative 4, okay, negative 4 is 1, 2, 3, 4. Negative 4, so greater than that, okay, so that's anything to the right of it. And when x is less than the value of 2, 1, 2. Aha. Okay, so there is an interval here. Highlighting in red. From here to here, our inequality is true. So what we've just proven is the very first function we started with, x, it is negative when it is less than and equal to our negative 1, and greater than and equal to our negative 4. So this is one of our answers. So case 2 helped out. It gave us something that was useful. It's getting very laggy here. So case 2 checked out. Now we try case 3. We set this one to be positive, this one to be negative, this one to be positive. Okay, hopefully I haven't memorized my positive, negative, positive. Actually, what I'm going to do is pause this for a second. Case 3 now. Case 3, we got the first one, so negative 2x minus 2 is, we want it to be positive, so we say greater than 0. X plus 4 is negative, so less than 0. And x minus 2 is greater than 0. All right, set up these number lines. Negative x greater than negative 2. X is less than negative 1. X is less than negative 4. X is greater than 2. Okay, so we got our number lines. We set up all three and see where all three end up being the same.
That 2 wouldn't change signs?
This one here?
No, this one.
Yeah, it did. It flipped.
No,
Oh.
but like the negative 2 would become positive 2.
Oh, yeah. Did I mess that up in the other ones? Uh-oh. Let's check.
No.
Oh, because it was positive there. I made a mistake. Here, it should have became positive and then negative. Okay, good. At least we didn't mess up. Or I didn't mess up the first couple. That would have been a lot of work to redo.
No.
Okay, here's our 0. Set up our number line. And we read them. So at negative 1, x is less than negative 1, so that's anything to the left of it. Negative 4 is over here. Anything x is less than, anything to the left of it. And x is greater than 2. Whoops. There's our 2. Anything to the right of it. Do any of three, do all three overlap? No. So case 3 was kind of a wash. Didn't help us out. Now we try case 4. Negative, positive, positive. Okay, let's set it up. Case 4. Negative 2x minus 2. We said negative, positive, positive. Are those the right functions? Ooh, finally memorized them. Okay. We bring the 2 over, it becomes positive, so x is greater than negative 1. X is greater than negative 4. And x is greater than 2. Sounds right? I think those are right. All right, get our 0, plot it out. When x is greater than negative 1, okay. When x is greater than negative 4, whoops, line there. Okay, oh, we got 2 of them working out pretty good. And when x is greater than 2. Okay, good. So here's our third one that's true. Our third one that's true states that from here to the right, yeah. So when x is
Greater than 2.
X is greater than or equal to the value of 2, our function is true. So we should really pull all our answers together here. We have our answers in the first one. It's lagging quite a bit. There you go. Do we not have something here? That was our first one that was true, highlighted in green. So when x was between negative 4 and 1, and in our second page, when x was greater than 2, these are all our answers when the function is negative. So if I take our factor form of our function, does this up? Yeah, I do. I take our factor form of it. I think I have it almost memorized now. 2x minus 2, x plus 4, and x minus 2. I think that's right. We zoom out a little. Okay, so these are our intervals. We said it was negative when it was between negative 4 and 1. That's right. That's where it's negative. And anything to the right of 2. Perfect. Worked out great.